It's the Gardenerd Tip of the Week podcast where we spend time chatting with expert gardening guests and we ask for their favorite tip. I'm Christy Wilhelmi. Thanks for joining me. This week we have Jeff Lowenfels back on the podcast. He is the author of 5 books, including his newest addition to the Teeming With series. It's called Teeming with Bacteria, the Organic Gardener's Guide to Endophytic Bacteria and the Rhizophagy Cycle, which is a mouthful, and we're going to get into that. He joins us today from Alaska, where he lives and gardens, and he has been writing the longest running garden column in the world for the Anchorage Daily News. Welcome back, Jeff.
I am pleased to be here.
Yeah, I recently saw your presentation at GardenCom, and I thought, well, this is the perfect time to get you back on the show. And the last time we talked was in person in 2018 at the Heirloom Expo, amid the sounds of bluegrass music and seed exchanges and lectures on growing food. Since then, you've written a couple more books. But before we get to your newest, let's check in with Alaska. What's it like growing in Alaska these days?
You know, Alaska is the canary in the coal mine. We are the place where climate change has been proven. I don't care who you are. I don't care how big a skeptic. Climate change exists. It's just that simple. The growing season is added since I've been there in 1975. When I started writing the column, it's grown probably about 20, 25, 30 days. It's unbelievable.
Wow.
And over the years from 1875 to now, it's well over doubled itself. I mean, they had no growing season whatsoever. And today, my God, we can grow anything. And we do.
And really big too, because you have incredible day length at that.
No, it has nothing to do with the day length, believe it or
Doesn't.
not. It's the soil.
It's the soil.
The soil contains an unbelievably high number of microbes, literally more so than almost any other place on Earth. And of course, it hasn't been degraded by chemicals and chemical gardening. So the soil is what grows those big cabbages. We can't grow it in Anchorage because the soil, those big cabbages and the big pumpkins, you got to really feed. And in the Matanuska Valley, the soil is there and the microbes feed like crazy. In Anchorage, that stuff has been moved away.
Right. That's where we get the Alaskan humus.
Right, exactly.
Soil that people use to make compost,
right.
Compost tea, right?
Yeah. So anyway, it's the microbes, and gardening in Alaska is a place where you can use the microbes, and we do. It's really
all right.
Yeah.
Now you just won a gold medal Garden Media Award for your newspaper column we were just mentioning, and it, as I said, it's the longest running newspaper column in the world. How long has it been running, and what is there still to talk about?
Yeah, this is where I break down and cry. It's 47 years long, I think.
Wait, 47 years?
Yeah. You know, and I used to say before the New York Times article came out that we were going to talk about, I used to say that I never missed a week, but in fact I did miss a week and I was robbed. I always tell people the reason why I have the column every week is because they put your picture in the paper when you're not around. They say he's on vacation, he'll be back. That to me always said rob his house, and sure enough, that's what happens. So I always have a column, no matter where I am. There's always a column, and it is tough to come up with new stuff. Now, we've had a lot of advances in terms of gardening. When I first started writing, everybody gardened according to their grandmother's method. Is what you learn from your parents or your grandparents. It was very rarely were you a gardener based upon your college degree or anything. Today, I think we're much more educated, and we have much more educated people telling us how to garden. So it's a different kind of gardening completely. And in Anchorage, we've gone from chemical gardening. The predecessor to my garden columns was a real big chemical head, and we don't use chemicals in Alaska anymore. I mean, it's just if you do, you're ostracized. It's just who would use chemicals in today's world? I mean, it's just the stupidest thing in the world. So we've become very organic, and my columns are very organic oriented, and that's the way they need to be.
Interesting. And what was the topic of your last column?
literally the one that came out today was there's been a series of articles about leaves. My article about a month ago was do not rake your leaves. The only place you need to remove them is from your porch and maybe your driveway and path. They will not smother your lawn. Leave them there, no pun intended. And of course, you get one or two people who write and say, well, you're crazy. You're going to smother the lawn. Now, there has been a gazillion articles since then in the national press about the very same thing. Well, of course there is, because that's the only way you're supposed to be. But today I got a letter. Today's column was about a letter I got from a 10-year-old. It's adorable. And she said, boy, it's a great idea. Yum for the worms. But I make my money raking leaves and I want to
Oh,
buy an iPad. Would you please tell your readers that if a 10-year-old knocks on the door, let her rake the leaves? So I had to write this, this, it's a conundrum, and you've got to learn, even though you want to do something, it's not good for the environment. You don't do it, even though you want to. And so there are other things you can be doing, and I listed chores that 10-year-olds can be doing.
oh, that's
Uh,
a good solution. That's
yeah,
great.
yeah.
That sounds like a really cute letter that was
Yeah,
well
yeah,
intended.
a brilliant kid. The kid's just a neat kid. So yeah,
Yeah. Well, let's dive into your book. So this is
sure.
teeming with bacteria. You've got teeming with microbes, teeming with fungi, teeming with what's the other one?
Teaming with nutrients and
Nutrients.
teaming with bacteria. So
Right.
that's the team, and it's spelled TEAM, not
Right.
TEEM. And this particular book I wrote because the 2006 version of the Soil Food Web has been amended as a result of the discovery of a special role that bacteria play. So the 2006 book, Teaming with Microbes, which everybody should read, not because of me, but because you really need to understand the soil food web basics, which Dr. Elaine Ingham came up with
Hmm.
and codified. And it works this way. You have sunlight, photosynthetic energy. Some of that energy is used to produce exudates that drip out of the root system that are specifically designed to attract bacteria and fungi. They, in turn, attract nematodes and protozoa that eat the bacteria and fungi and poop out the excess. And it turns out to contain nutrients in plant usable form. They have a charge on them, the proper charge. So the microbes put a charge on the nutrients, and the nutrients then move from the soil into the plant, which is what teaming with nutrients describes. How that happens, how they get in the plant, what happens when they get in the plant. So, okay, so everything's happy. I had a paragraph on mycorrhizal fungi back then in 2006. I had to revise the book in 2011 or 12 in order to add a chapter on mycorrhizal fungi. And then in 2018, there was finally enough information to cover mycorrhizal fungi in a book. And lo and behold, it turns out that the whole system gets added by a discovery that was made in 2010 called rhizophagy. So some of these bacteria that are attracted by the exudates, they don't get eaten, but instead they move through the meristem cell walls of these brand new cells that are in the root system. They're called meristem cells. If you took a meristem cell and put it, on a green part of the plant, you create a fruit or a broccoli or whatever, a different part of the plant. But here they're in the root, they form roots. The bacteria move through the cell wall and they find themselves in this space called the paraplasmic space. The example that I use on these podcasts and whatnot, if you think of a tofu container,
Hmm.
that white plastic stuff is the cell wall of the meristem cell. Very thin, very immature, very simple for the plant to move through. I mean, the bacteria to move through, and it ends up in the liquid which surrounds the tofu. The tofu represents the cytoplasm. It has a membrane around it. But these guys don't go in there necessarily. Some do, but they really end up in this liquid space, the paraplasmic space. When they move through, the plant goes, wait a minute, and sprays them with a substance called a superoxide. this superoxide is strong enough to remove the cell walls of these bacteria, and they end up wall-less, but they're still alive. In order to protect themselves, they try to weaken the superoxide, and they spray the plant cell wall with nitrites. These get converted into nitrates, both the cell wall of the bacteria as well as these nitrites, which get converted to nitrates, get absorbed by the plant and get into that actual tofu where they do things, enzymes and form molecules and all that kind of stuff. Meanwhile, you have these alive wall-less bacteria that multiply every 20 minutes. And so they multiply and they get circulated in that periplasmic space. And as they multiply, they're continually spraying nitrites onto the plant spraying it with this RO. And the RO, incidentally, has the capability of damaging the plant cell wall. So it has to strengthen itself in order to be able to handle it. This lasts the lifetime of the plant. In the meantime, these plants the bacteria are producing ethylene, which is a phytohormone that causes the meristem cell to grow, to stretch out and grow. And it does so, and it keeps the system moving. And lo and behold, you end up with more and more bacteria. And eventually you get so many bacteria, they don't circulate the same way. They get caught against the cell wall. They're producing ethylene, and the ethylene isn't circulated anymore. It's concentrated, and it makes a tube form in the meristem cell. You and I now know these tubes to be root hairs, but what's really happening is these bacteria are backing into these hairs as they're forming. They literally are exploded out of the root hairs, sometimes 5-6 times during the growth of the root hair. And when they get squirted out of the root hair, they end up growing back their cell wall, saying to themselves, gee, that was fun. And a couple of days later, they repeat the trip. Holy crow. So these are rhizophysi bacteria. They form the cell wall. If you don't have these bacteria, you do not get root hairs. If you don't have root hairs and put these bacteria back, root hairs are formed. So the takeaway is that root hairs are not for nutrient absorption. They're for propelling these wall-less bacteria back out into the soil so they can regrow themselves and become useful. Now they end up being very thin-walled, these root hairs, and they will absorb nutrients, and obviously they do. They provide the surface area, blah, 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 but it's really there for the bacteria, not for the nutrients. What a wonderful system. So the soil food web now has farming capability. Plants have farming capabilities. They can do this wonderful, throw the exudates out, get the bacteria and fungi eaten, and get those nutrients and take them in. That's farming. This is ranching, where they're taking this bacterium, they're stripping off the sheep wool, they're taking a lamb chop or two, and they're putting it back out into the pasture, it's growing back its wool, and then the plant repeats it again. So this is a major addition to the soil food web, really discovered by this Australian team, but beautified by Dr. James White from Rutgers University. And it adds to Dr. Elaine's soil food web in a very important way. You can get up to 30 or 40% of the nitrogen of your plant from this system. Wow.
It's very impressive. And
very new, which is why nobody's ever heard of it.
Right. And so you explain it really well. There's a lot of biochemistry in the book and a lot of illustrations that help people understand what this means. And it seems like it might be a little bit intimidating to readers, but it's really well explained and worth the read in order to understand it. Now, I
tell people the reason why it is because I'm a lawyer. I'm not very smart. And so I had to dumb this stuff down so that I could understand what was going on. It's, and so that's what I do. I dumb things down, and I really dumbed this down.
I will say that you break it down so that it's understandable and digestible components.
Thank you so much.
And I just really out of curiosity, because there's the beginning of the soil food web is bacteria and fungi, but these endophytic bacteria are different in some way?
Well,
Or do they share a role, kind of like how bees
yeah.
change their role in the hive?
Well, let's get into that for a second. First of all, there are endophytic. Endophytes are organisms that enter into a plant, live there part of their life, at least.
Mhm.
And so the rhizophagy bacteria are endophytic bacteria. There are endophytic yeast that do the same thing as in rhizophagy, not as many, the bacteria, different varieties. And there are endophytic fungi, which is what really mycorrhizal fungi are. They live part of their life, or at least part of them live inside the plant. So we're familiar with them. Rhizobia, which we
Mhm.
know for nitrogen fixation, those are endophytic. But there are other bacteria that enter into the plant by getting into the cracks and roots, by going in through injuries, and they get into the plant. And once they're in there, they travel through the system, and there's sugar in there. Why would they want to be in the plant? One might ask, because there's no competition. There's food there. They can travel around, and while they're in there, they're producing phytohormones. Bacteria produce phytohormones, plant hormones, auxins, gibberellic acids. So these ethylene. These are all things that plant use, and so they strengthen the plant and have the capability of helping their plant partner, who are giving them this wonderful environment to live in. And so as a result, they help the plant deal with abiotic stresses like temperature, like wind, vibration, all those kinds of things are aided by the phytohormones that are produced, one of the 5 or 6 phytohormones that they're capable of producing, or they are fighting off pathogens. So they're the biotic stress. They say, wait a minute, this is my house. Get the heck out of here, mildew. And so they get rid of them. It's fascinating. It's just a terrific system. Now they've always been there. We've known they've always been there. But what's the difference is that with rhizophagy coming to fore, the thought is we really are not only going to be able to feed our plants a kind of bacteria that's going to provide that particular plant with a kind of nitrogen and amount, and so that we don't have to use chemical fertilizers, but we're also going to be able to put some of these endophytic bacteria on a plant and have them do various things, so that we'll be able to grow things in Alaska where the temperature gets a little bit cooler.
Mhm.
Maybe our tomatoes will flower at less than 55 degrees, or we're going to be able to have on our grass plants an endophytic bacteria that can jump off and kill the dandelion in the lawn and then get back on. All of these things are happening, and what I call the so-called evil agro businesses, they're all studying these endophytic bacteria so that they can replace a lot of the stuff that they use, pesticides, herbicides, and fertilizers included. This is a wonderful, wonderful thing that's happening. And in this book, Teaming with Bacteria, you'll get a flavor of that. And you'll get a feel for why this is important. And again, if you use Google as your tool, you may end up getting notification of when these things become available, because they are becoming available.
Well, that's exciting.
Yeah.
Now, you mentioned in the book that there's a relationship between endophytic bacteria and seeds. Can you talk a little bit about that?
Yeah. It's interesting because the endophytic bacteria end up inside the seed, and because they get into the flower, etc., and they're just in the seed coat or underneath the seed coat. A couple of them maybe in the embryo, I'm told, and they're there for the plant when the plant is germinating, and they hop off the seed, get into the soil, and provide the plant with the kind of bacteria that it needs, be it a rhizophagy bacteria or some of the other endophytic bacteria. So if you have a corn plant, for example, that was bred or used, one of the early one, grassy kind of corn plant from 400 years ago, and plant that plant today, the seeds have the same bacteria that they had 400 years ago. And even through breeding, a lot of the bacteria remain the same as in the corn plant. So strains of plants are as a result of the bacteria. Your heirloom tomato is different from my heirloom tomato, perhaps, because we've had some bacteria jump into our plants that aren't in the bacteria in your plants. It's
Which makes
fascinating.
sense for people to buy local seeds if they can, for
Right.
that'll probably grow better in their area if it has that bacteria.
Well, I mean, that's by the definition of heirloom. I mean, that's
Right.
really what it is. Yeah.
Yeah, but you mentioned, because you mentioned in the book that you think, and I agree, that treated seeds should be stopped immediately, that no one should be treating their seeds or cleaning, because there's a process by which they
Well,
sanitize seeds for shipping so that it doesn't come with anything on it.
yeah, yeah. People still, I mean,
Sterilize it.
sterilization of seeds is
That's the
terrible.
word.
And cotton is the real plant. They do so much on cotton seeds that cotton uses more pesticides than any other plant that we grow. And it's because the seeds don't have any bacteria, that would be protecting the plant. These bacteria, they go out and get metals, the cenophores, and they do all sorts of things for the plant. And again, the fact that they can produce these phytohormones, nobody ever told me that.
Mhm.
It's amazing, just simply amazing.
So what should people do to promote these bacteria in their garden soil?
So, are you asking me what my tip is?
No, not yet. We're going to get to the
Uh,
tip after this, but
okay, well,
yeah.
all of the things that Dr. Elaine Ingham has suggested, and that are certainly in Teaming with Microbes, should be practiced. There, all of those rules. There are 19 of them in the back of Teaming with Microbes. No rototilling. No sterilization of seeds or soil. Using mulches. Making sure that chemicals are not used. When you use a chemical, you change the nitrogen efficiency ratio of these microbes. They don't work quite the same way. And so all of the things that you would do using organic foods, putting those organic foods into the soil so that the soil ends up feeding the microbes feed the plant. Knowing when to do these things. You can't put down an organic fertilizer and expect it to work right away. It has to be broken down. And so all of these things are listed in Teaming with Microbes. They're all the things that organic gardeners do generally, and that's what I tell people to do to preserve these bacteria, because bacteria, fungi, doesn't matter. We want to protect all of the microbes.
Right. Exactly. And I've read Teaming with Microbes. It's a great book, listeners. Everyone should read it. And if you happen to, I read it as I was taking Dr. Elaine Ingham's
Oh, wow.
soil food web course, and so it went in easier
Yeah, yeah,
because of those two things together. So I
right.
recommend them in partnership, actually. All right, now it's tip time. Do you have a favorite tip you'd like to share with the Gardenerd
Yeah,
audience?
my favorite tip is mulch. There is no bare soil in nature, and the mulch is just compost in the making. If you use brown mulches or what I call full mulches, in other words, full leaves, you're gonna promote a lot of good fungal growth. You'll get bacterial growth too, but you're gonna really get great fungal growth. If you pulverize those leaves, or if you use green mulches, you're going to end up with some fungi for sure, but you're also going to end up with a lot of great bacteria. And you want both of these things in your garden, depending on what you grow. As you know, Dr. Elaine Ingham has a chart from the beginning of plants all the way to the old growth forest. And of course, what happens is the more plants you get, the more fungal material you get all the way through. The bacteria number basically stays the same. So you want them both, and you want to make sure that you use mulch.
Right. We're talking about plant succession and how when in
Right.
grasslands, grasslands are bacterially dominant, forests are fungal dominant, because the more perennials you get, the more fungal the soil gets, usually.
Well, yeah, what I say is the more debris you get, and
Ah,
obviously the more plants you get, you end up with
that's right.
more and more soil and fungal soil. Yeah.
Yeah. So, but you said something interesting there, that the bacterial numbers stay relatively the same throughout all of that. It's just
Yeah.
that the fungal numbers grow toward the forest, the more acidic slash forest side of things.
Right. And wow, do they grow? I mean, it's like 50 to 1 at the 50 to
Yeah.
1 fungal, and 0 to 1 fungal at at the beginning of the grass cycle. So yeah, I mean, and the trick is to figure out where your plants are on that continuum. What I use is the system. If it's in the ground more than a year, it needs more fungal than bacterial. If it's less than a year, it needs more bacterial than fungal. I've been misinterpreted as saying, some plants are all fungal, all bacterial. No, 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 no. You need at least 5 or 6% or more of fungal. You just got to have it. So
Yeah. And do you rely strictly on mulch, or do you brew compost tea as well?
On my yard, I've been gardening in for so long. I use compost tea every now and then,
Mhm.
mostly because I like to use it in the greenhouse. And so if I have some, I'll go out, and it never hurts to use compost tea as far as I'm concerned. But I don't really need it anymore. I had a period of time though when our backyard was so hard pan.
Mm.
There wasn't a worm around. I never saw birds. And boy, one season of compost tea, and then I'm telling you what. Now there are people who say compost tea doesn't work. I don't agree with them.
Yeah.
And I know that sounds so unscientific. I've experimented with it. It seems to work for me.
Yeah.
But I can understand it's a living organism, and if you've already got it, putting more in isn't necessarily going to help. So
Right. If your soil is already biologically active, you're not adding too much more to it. But
yeah,
for those, because I've done the same thing where I've taken really crappy soil and put down lots and lots of mulch and then put compost tea down, and it's turned into like digs
yeah,
like butter now,
yeah. Absolutely, absolutely. I mean, I've got so many different compost tea brewers. I love making it. I love the smell of it. It's really fun. And one of the take homes with it with this particular book is if you can mulch your plant with material from that plant, it's going to be adding to the wonderful bacterial mix that it needs. Not always capable of doing, well, gardeners break what I always call the law of return. We harvest. And when you harvest, you're not allowing the stuff to go back down into the ground to feed the plant. So that's gardening for you. We have to be the sheriff in town that says, no, you broke the law of return. Now you're going to have to fix it. And that's what organic gardening is all about.
Well, those are all great tips, Jeff. Thank you so much for sharing that with the Garden Nerd
Pleasure.
audience and for being a guest on the Gardenerd Tip of the Week podcast. What's the best way for people to find you?
I think the best way is just to follow my column at adn.com. adn.com. Every Friday, Thursday night, Friday, you'll find my column. They're usually, short, funny, and organic.
Excellent. And we will share that link as well as a link to all of your books on gardenerd.com this week. We'll also share a fun little article that the New York Times did on your garden column that people won't want to miss. So check that out, Garden Nerds. And thanks for listening. That's it for this week. Subscribe to this podcast on Apple Podcast or wherever you listen. Visit us for tons of free gardening information at gardenerd.com. Show your support for this podcast and the other free stuff on Garden Nerd by becoming a Patreon subscriber. You'll find us on Instagram and Twitter under GardenNerd1, on Facebook as gardenerd.com, and of course, our Garden Nerd YouTube channel. Happy gardening.